Hello everybody, welcome back to the channel. It is me, the Master. Thank you guys for coming back. And in this video, I'll be going over SAT Math practices number 3, no calc and the no calc section. And I think then we will go back and finish practices number 9. These videos are completely out of order, by the way, no regard whatsoever. I don't know why I finished practice test number 10's no calc section and I said I wouldn't do it again. But here we are. So I'm just jumping around, I guess. Yes. So this is the video where SAT practices number 3, the math no calc section. I think I've only made no calc section videos. I need to make a with calc section video, and I think I'll do that soon with practice test number 3. I've just gone over this section multiple times. Like, I really remember these problems and the best way of doing them on the top of my head to help you guys with these problems. This is not a hard test overall. As I said maybe in my video when I was discussing practice test number 9's no calc. Um, but it is still filled with awesome problems. So let's get started. Good to go. All right. So this one says, number 1, a painter will paint n walls the same size and shape in a building using a specific brand of paint. Okay, the painter's fee can be calculated by using this expression NKLH, where n is the number of walls, k is a constant with the units of dollars per square foot. So dollars per square foot, something like that, right? L is the length, H is height, makes sense. If a customer asks the painter to use a more expensive brand of paint, which of the factors and expressions would change? So if we're using more expensive paint, right, it's probably going to cost more. So we're looking for one that'll probably affect the cost. Let's look at our options, or let's look at these letters. N, the number of walls. Number of walls has nothing to do with it. Eliminate D. L is the length of each wall in feet. The length, you're not changing, you can't just change the length of the wall. You could ask them to do a different wall, but no. H is the height. Oh, length of each wall in feet. H is the height of each wall in feet. Oh, this is length, this is height. Nope. Nothing to do with it, it's K. C. Okay? Because that's the only one referring to K is the constant, which represents the units of dollars per square foot. So that one will actually have an effect on the cost and the price. Okay? So, yeah. That's the only one. That's the only one that is the correct answer. Okay, pretty simple. I think y'all can see number 2, but I'm still going to scroll down anyway. And I think 125% zoom in looks best. If 3r equals 18, what is the value of 6r plus 3? An easy way of doing it. There are 2 ways of doing this problem. I'll show you all both ways. Way number 1 is to find r individually. So you're like, okay, 3r equals 18. So then I'll be like, okay, well then r must equal 6. And then I substitute 6 times 6 plus 3 equals 36. 36. Sorry, I'm just making more room, y'all. Okay, there we go. 36 plus 3 equals 39. That's one way of doing it. Okay? The other way of doing it, which I'll show y'all. I'll probably increase my racing tool. Oh, frick, I forgot, y'all. This isn't clicky. I'm like, it should do something. Okay. The other way of solving it. Oh, okay. The other way of solving this is to say, okay, well, they're asking me for 6r plus 3, so 6r must be equal to the double of 18, which is 36, and then just a plus 3, which is 39. Same thing. This is actually a shorter way of doing it, but you can try both ways. So this is way number 2. Okay, just using the information we're giving for. We're not solving for anything individually, and we're not substituting. We're just transforming the equation into the one we want. So here are 2 ways of solving the same problem. I think some of y'all might like the first way more, but the second way is better, like time saving wise, I guess. So yeah, and here's another thing, y'all. What I used to do though, okay, on SAT math, is like the first questions are so easy. I used to be so ahead of time. I'm like, I have so much time to spare. I'm just gonna take my time, make my way through them, slow down, I guess, just chill out, and then eventually the hard problems come and I get stuck on them, and the time just flies just like that. Don't do that. I have a really big ego in the SAT math section. I can't help it. But don't do what I do. I stop taking time for granted. If you have extra time, good. Use it. There might be a problem that might stump you later on. Even if it's the last one. The last one might take you like 5 minutes or something. Let's say you had like 10 minutes to spare because the rest was so easy and you're going so fast, and then you realize, oh shoot, if I didn't waste my time, I could have had extra time on this problem because I had the time. I just stopped caring. Because here's the thing, y'all. There's a chance that there are generally two types of places where SAT math questions could get tricky. Either in the middle of the test, those are what I call at least stumper questions, because they come after a series of just super duper easy questions. You're on a winning streak. You're doing really good. The time is fine. And everything. You're solving everything, going super well, and then one of the tricky problems come towards the middle of the test. Those are what we call stumpers. There might be one or two of them to kind of slow people down who have a really good momentum so far, and then they'll eventually lose time towards the end of the test because they're stuck, focused, trying to solve that one. They're getting tricked, and they're wasting time doing that. The other type of hard master questions, which is also pretty popular, is towards like the one like last few couple of questions, which might be hard. Though they're just there to make sure like you can at least like do the hard problems also. But yeah, so those are the two kinds of hard problems for ST math. I think that usually there are. Moving on. Okay, number three. Number three. I like three because it's so easy. Which is the following equal to a to the power of 2/3 for all values of a. So remember, if you have an exponent, the numerator is basically the power. So it's still a to the power of 2. It's basically a to the power of 2 times a to the power of 1/3. A to the power of 1/3 is nothing but the cube root of it. So we're looking for, with everything applied, the cube root of a squared. So that's not it. That's not it. Um, yeah, it's this one. Okay. Don't be confused by option C. It's somewhat of a distractor. This one is a pretty easy one. I don't know when you guys learn this, maybe in algebra or something, but super easy problem. Okay, this one is also easy. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900, okay? Which makes sense if you think about it, if you live with the US at least. Like geographically speaking, I guess, America just won its independence in 1776, and then just the number of states just kept on adding to the Union. So we got like 30 states up to 1849, and then between 1850 and 1900 kind of slowed down. I think we got like maybe a few states, maybe like I don't know, maybe Texas or maybe Hawaii, maybe Alaska, like some kind of those states, maybe I don't know. But the main point is 30 states joined between 776 and 1849, which means half of that, 30 over 2, 15 states joined from 1850 to 1900. So that's what they're asking for, right? X states joined. So X is equal to 15 then. We basically answered that question ourselves. But they're not asking for X, so that's which equation is true. 30 times 15 is 2. Nope, that's wrong. 15 times 2 is 30. Yep. I guess you can just quickly breeze through the other ones, but they're both wrong. So, yeah. We'll circle. I'll just circle the letter from now on. I lost my faith in circling you guys. Okay, number 5. Number 5. If 5 over x equals 15 over x plus 20, what is the value of x over 5? Yeah, I'm zooming. Let me try 2. No, 175 is too much. 150 is more of a sweet spot for me. 125 is just not enough. I like to make things big, maximize them out, and maybe this helps you guys see better. I really don't know. But let's see. So first you got to solve for x, which I think is a good approach to do, I guess. And the best thing to do in this case is to just cross multiply, I guess. You don't need a common denominator because you're not adding or subtracting anything, I believe, right? Yeah, you only need a common, remember, here's a rule, right? You only need a common denominator when you're adding or subtracting things, terms, whatever. But here, when they're already said to each other, I think you can just go ahead and cross multiply then. I think it'll save quite a bit of time by doing that. That's a logical approach in my sense. Okay? Because even if you get a common denominator, what good is it going to do? Literally nothing. Alright? Let's cross multiply. I usually cross like this first and then this kind of that cross x. So we get 5x plus 100 is equal to 15x. Okay. So what is it? 10x is equal to 100. That's what it is. X is 10. Okay. So x over 5, 10 by 5 is 2. Answer is 2. And I mean, I guess you can plug and play. 5 over 10 is 1/2. If you plug in 10 here, you'll get 15 over 30, which is also 1/2. So basically the same thing. Boom. Okay. I think that answers that. Hold on. Okay. Here's somewhat of a stumping question. If xy is the solution to the system of equations above, what is the value of x minus y? Not a calculator allowed question. Maybe you really don't need calculator for this in the first place. But what does oh frig, I'm thinking of the completely wrong problem. No, sorry, we're not there yet. I was about to think about spoilers. So basically, you have these two equations, and it's just asking for what's x minus y. And here's the thing, right? You might try to like think of like a matrix, or add, or subtract, or multiply, which one should go where. You might think, okay, well, if I need x minus y, what if I take this bottom equation and subtract it from the top equation? I still don't think you can get x minus y in that form. An easiest thing to do would probably just be to solve for one term first, and then find the other one, algebraically speaking, and then find x minus 5. I think that might work out. Okay, and usually since they're in 2s or 3s, you'll multiply one term by 2, and one equation by 2, and the other equation by 3. Works out pretty well. So let's multiply this equation by, let's multiply this one by 2 or 3. Which one do I want to keep? How do I want to keep it? Now let's multiply this one by 2 and this one by 3. Okay. So we'll get 4x minus 6y equals minus 28. And here, multiplied by 3, we'll get 9x minus 6y equals negative 18. So I can cancel my y's out. Alright, now one important thing to know is should you add or subtract when you're at this stage, okay? Because it's important to know. You can either do either one to both equations, but you gotta know when to do which one. Alright, so let's take a look at our equation here. Here we have negative 6y and negative 6y. If we do add, we're not really changing anything to the signs, and then it's going to come negative 12y. But if we subtract, then we're actually making a change here, because in this bottom one will become a plus. 4 minus 9, we get negative 5x equals, I'm saying equals because like, there's nothing left on the left side, the y's are going to cancel out at this point. Negative 28 plus 18, okay, so that should be negative 10. What does that mean? That means that x equals 2. We're almost there now. Now we can just solve for y using either equation. I guess we can use the bottom one. So 2 times 3 is 6, and 6 minus 2y equals negative 6. So we can say negative 2y equals negative 6 minus 6 is negative 12. So y is 6. Okay, and you can plug it into this equation too and double check. 2 times 2 is 4. 4 minus 18 is negative 14. So it works for both. So asking for x minus y, that's 2 minus 6, which is negative 4. Answer is C. Alright, that's probably how I would do it. There might be some other ways of doing it, but this way kind of makes the amount of sense. And they're just testing your algebra, y'all. Okay, number 7 is one you should know how to do. Like, in algebra, they should have touched how to do this, or maybe forgotten, and I'll explain. The function f is defined by a polynomial, and a calculator probably isn't even going to help you in this question because you don't even know what the original equation is. Linear, quadratic, exponential, to the power of 2, 3, 4, you really don't know. I mean, you could graph it, but that's not going to help you out. Like, it's just a waste of time. So they're asking some values of x and f of x are shown in the table above. Okay, we got x and f of x. Which of the following must be factor of f of x? Okay, factor. So let's see. Since they're all, and luckily they're all in the form of x minus h, where when x equals h, then f of x becomes 0. Okay. So let's see. When is the y value 0, not the x value? Some people might go ahead and pick 3 or something. I don't know. When is y 0? Right here at the point 4, 0. 4, 0. Imagine this is 4, 0, and then we got like this point 0, 3, got this point 2, 1, 4, 0, and 5, negative 2, something like this. Maybe it's a parabola, and maybe it'll go up eventually. But we can't say anything what happens beyond these points. But we do know that at 4, the y value becomes 0. So a factor has to be x minus 4. When you divide it or something, you get no remainder. So anyway, it's x minus 4. 7 is C. Okay. Alright, number 8. I love this problem because it's just a good problem to do. The line y equals kx plus 4, where k is a constant, and I think it's usually slope. You guys know the slope-intercept formula? I think that's what it's called. Where usually it's the equation form. It's one of the more common algebraic formulas. Y equals mx plus b, where b is the y-intercept, aka the value of y when x equals 0, and m is our slope. In this case, I guess k is our slope. If the line contains the point CD, so basically you can plug in D, what is the slope, which is basically K. So you can see that D, I'm just plugging in here, so D is our Y, right? The point CD, let's say here's our point CD, right? CD, that's our point, right? Basically our Y then equals D. So D is equal to, and then just plug in the rest, K, and then for x we have C, so it's KC plus 4, and you want K by itself. So we'll subtract 4, so D minus 4 equals KC, okay? And now we would just get rid of the C. So divide by C on both sides, divide by C, so we're given K equals D minus 4 over C, which is option A. Alright, cool. We're getting there, y'all. We're getting there. We're building concepts, right? Confidence 2, it's coming. This is the problem I was talking about. Here we go. And the system of equations above k is a constant x bar values. For what values of k will the system of equations have no solutions? So there are 3 examples of solutions. One is having one solution. That's what I was going to talk about, which is at a single point x, y. And you'll have to see where they intersect, usually by setting the equations equal to each other or something. Finding a common point. The second one is IMS, infinitely many solutions. When the equations are basically the same thing, like you have like y equals 3x and another y equals 3x. They're going to overlap entirely. So they always have a solution everywhere. No solution, third one, no solution, is like this. You have 2 equations with the same slope but different y-intercept, aka parallel lines. You know how parallel lines never intersect usually because they never meet? It's because they have the same exact slope, but just because they're the same y-intercept, they're never going to meet at the same point. For example, take like y equals 3x plus 4 and y equals 3x. Same slope, but different y-intercept. This is the y-intercept of 4 and this is the y-intercept of 0. They're never going to meet anywhere at all. If it's like y equals 3x plus 7, then they're still not going to meet anywhere. But let's say it's y equals 2x plus 7, then there would probably be one solution. Okay, but no solution is on the same slope. So what's our slope gonna look like? Well, let's find out. Alright, I'm gonna erase this now. Let me erase this. Okay, so that's kind of like a brief overview of solutions. So I think now you guys might be ready to solve this problem. Again, I'm trying to provide you with enough context and enough knowledge to help you guys solve these problems, but if you have any further questions, please feel free to reach out, or all can help each other, whatever. I don't really care, as long as we're understanding. That's my goal here. Okay, so this one, this is, I forgot even what form this is called. It's like that mx, or something, ax plus by equals c form. Yeah, that's the form. I don't even know who came up with this formula. Like, we never usually use this. Ax plus by equals c, where c is just a constant number. Yada yada yada. Anyway, so let's find the slope. So we can say that 4x minus 7 equals 5y. Just a little bit of rearranging. And then all we need is a slope. I really don't care what comes after that. Our slope, our m, or k, is equal to 4 by 5. No, sorry. K is not 4 by 5. Our m is 4 by 5. K is not the slope. It's just a value, I think. Yeah. And that's because this is also in the form ax plus by equals c. We have to change the form to get 4 by 5. So we'll get kx minus 4 equals 3y. And then we're going to divide by 3, of course. Get rid of the y. Divide by 3. Now we can say that, okay, k by 3 equals 4 by 5. Alright, making sense? Cool. So now we can just cross multiply again like I taught y'all earlier. So we get 5k equals 12. So k is 12 by 5. Boom. That's the answer. 12 by 5. Alright, this might be a stumper question for some of y'all, but I think y'all are pretty smart. So I don't know. Number 10. Ooh, a circle. I actually love circles, y'all. Like, one of my favorite shapes, circles, triangles, whatever, but this one I just really like for some reason. So this one, so I'm going to parabola with this equation, x minus 11 the whole square, so that probably means like 11, 0 or something, might be like a point, 1.5 probably, when the y value will equal 0, okay? And number 6, the line with the equation y equals 25 at 2 points. So you have two equations here with this quadratic equation and this line equation, y equals 25. And the circles intersecting 2 points A and B, they're not centers of the circle. One point is probably going to be like here, we can call that point A. And the other point might be here, we can call that point B. And then this is that line, y equals 25, running through it right around here. Okay, so what is this length, this distance AB, is what they're asking for. Okay, so when is one value we're going to get when the y will equal 25? So we have x minus, well, there are two values actually. Well, let's see if we can find both. X minus 7 the whole square equals 25. Let's take the square root on both sides. So square root. Okay, so we get x. Remember what I said, y'all, when you take the square root, there's only one option. So you get x minus 11 equals. But here's different. Here is solving for something, so it will be plus or minus 5. Okay? Because you need two solutions to find the 2 points A and B. The y value will be the same, though. It'll still both be 25. So x is equal to, let's say we take plus 5, we get 16. Let's say we take minus 5. Negative 5 plus 11 is 6. What's the distance from 16 and 6? Subtract, you get 10. The answer is A. Alright, 10 is 10. Alright. Okay. Let's do number 11 now. And I really like this one because I don't think we've ever done like a main geometry sort of problem. I'm not like the biggest fan of geometry. I like trigonometry more so, but geometry is alright. I mean, it just depends on the shape. But here got some rules for y'all to follow. And this equation is going to help us out a lot. So here's a quick geometry lesson. This whole thing is going to equal 180, and so is this. And all these angles, y, z, t, u, w, x, this whole thing will add up to 360 degrees. And I mean, you can tell because 180 plus 180 is 360. These angles equal each other because they're vertically opposite. So y and u, x and t, w and z. Just remember that, okay? Because I'm going to be referring to them like that. Okay? And feel free to have any questions about what I'm going to do. So it says in the figure above, lines K, L, M intersect at a point. If x plus y equals u plus w, which of the following must be true? It has to be something provable by the geometry, definition, theorem, formula, law, something, and we need to be able to prove it. So the first one is x equals z. Can we prove that? Well, here's something. Due to vertical angles, we can say that y equals u. So we can say that x plus u equals u plus w. That's one thing we can prove, right? So we can also prove that x equals w if we subtract u from both sides. So x equals w, and we know that w equals z, right? Directly we can prove that, because those are vertical angles. So by proving this and proving this, we can in the end prove this. X equals z. So yes, the first one is true. Okay? We have proven that. Very well. Alright? So that's the first one. So just keep it in mind. So option 1 is correct. And I need to erase it because I'm going to do more math on this. Okay? If I'm on usually like a paper or something, I just tend to conserve more space, but whatever. Can you try to prove the second one? Y equals W. Well, that's only possible if we can prove that X equals U. Can you prove that X equals U? No, we can't. We can't prove that X equals U. So for this one, we have to say no. The last one, Z equals T. Can we prove that? Well, let's find out. So let's say X, what is X equal to? X is equal to T. So I'm going to just substitute that in. Y again, I'm going to write as U. So we have T plus U, just rewriting the equation, is equal to U plus W. And what is W equal to? W is equal to Z. So cancel that. So yes, T is equal to Z. And we could also indirectly prove it in. We earlier said that X is equal to Z, and we already know that X is equal to T, so Z has to equal T. Alright, so yes, the third one is also true. So it looks like it's option 1 and option 3 only. So not that one, not that one, not that one. 11 is B. Okay? Just remember that. Okay. Let's see, number 12. Okay, here's a really good one, and I'm going to explain. I think there are other ways to solve this problem, but they take too long, so I'm going to explain all the shorter, so solving number 12. Here we have a quadratic equation. A is a non-zero constant. The graph of the equation the xy plane is a parabola with the vertex CD, which the following is equal to D. So here's the thing, right? I'm actually going to factor this out a little bit, just a little bit, into the form y equals a times x squared. So we have negative 2x plus 4x, which is plus 2x, and then we have 4 times negative 2, which is negative 8. Right? That's our equation, right? And here, I'll write it over here now. So now we're going to multiply by a, all right? So when we multiply by a, we're going to get y equals, let's see, ax squared. Whatever a is, we don't know what a is, and that's fine. We don't need to do that. Plus 2ax minus 8a. Okay, so here's our equation. And here's one thing to note. I think the formula for a vertex is our x value is negative b over 2a, and our y value is d over 4a. I think that's the equation where d is usually the discriminant. I think it's the square root, or b squared minus 4ac or something. It follows a quadratic formula, which we have already studied. But we don't need to do that. I'm just going to find the x value, which is negative b over 2a. So I'm going to write it over here. Negative b, our b term right here is 2a. So it's negative 2a. Okay. So that's our b term, right? Negative b over 2a, which looks like it's, well, this is 1. So it looks like it's just 2a. Negative 2a over 2a is, well, let's cancel this out, negative 1. Now we're going to plug in negative 1 into this equation, okay? That's our x value, okay? So when we do that, we're going to get, let's see, negative 1 times negative 2 is negative 3 times, and then negative 1 plus 4 is positive 3. So we get 8 times negative 3 times 3, which is negative 9a. The answer to that is option A, negative 9a. This was a bit of a, maybe somewhat of a trickier question if you didn't know how to do it, but that's how. Okay, so if you have any questions, just let me know. Alright, let's move on. Okay, here we have an equation like this. It's true for all values, x is not equal to 2 by a, where a is a constant, but is value of a. And if you can just look at it right now and just answer this problem in 2 seconds, you're good. Here's what's going to happen, right? Don't even worry about this part. Nothing else really matters, okay? So let's say you multiply the top and bottom by a over x minus 2, so you can combine like terms, but not, right? You're going to want to get a 24x squared. You need an x squared term, right? This 24x squared is going to equal ax, right? It's the only other one, right? With the x term, right? Okay. Yeah. So is equal to ax squared times negative 8 times negative 8. And you can cancel the x squared from both sides. 24 is equal to negative 8a. So a is equal to negative 3. That's literally it. Don't even worry about the rest. We're doing tips and tricks here, not solving the entire problem, okay? But yeah, that's how to do it. Okay, 14. What are the solutions to this equation? Alright, y'all, quadratic formula time. And we have to use it because, I mean, it looks like we have to use it. So you can kind of, just based on the way our answer choices look, alright? So x is equal to, and I'll write it out here. Our a, you guys, is 3, right, because this is a 3. Our b, you guys, is 12. This is a 12. And our c, you guys, is 6. So here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, that's a huge 6. I just wrote the number 6. I'm writing 2a now. There we go. Okay. Why don't I write C there? I don't know. There's so much in the song. What is our C? 6? Oh, okay. Got 4 and a 3 and a 6. There we go. So, that's basically that, okay? Let me extend this out. And the 6 follows for everything. That's huge, y'all. I don't think you're all going to be able to read that. But let's focus on inside the square root first. We have b squared minus 4ac. 4 into 3 is 12. 12 into 6 is 72. 144 minus 72. So this is 2, and this is 7. So this is also 72. So we have negative 12 plus or minus, I'm rounding up here, y'all, square root of 72 over 6. All over 6. So here we're going to get, well, negative 12 over 6 is negative 2. And then we have plus or minus. What are some factors that makes me all hit me? 36 times 2. So that's what, 6 root 2. Plus or minus 6 root 2. Well, this is the lower 6. So we're going to divide by 6. And it's just root 2. So it's negative 2 plus or minus root 2. Go to the answer choice A. Alright. Okay, 15. We have this Celsius Fahrenheit sort of question. And they're saying the equation above, it shows how temperature F measured in degrees Fahrenheit relates to temperature C measured in degrees Celsius based on the following, which the following must be true. Okay. Temperature increase of 1 degree in Fahrenheit. So for 1 Fahrenheit is equivalent to a temperature increase of 5 degrees Celsius. That is absolutely true. Our slope is 5 by 9. A temperature increase degree of 1 Celsius, not Fahrenheit. So we're kind of flipping it. So now it's going to be 9 by 5 is equal to a change temperature of 1.8. Yep, because that's 18 over 10. And if you move the decimal point, you get 1.8. So yes, this is also true. A temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Nope, that is not true. Okay. So yeah, third option is wrong. So it's 1 and 2 only. So 15 is D. Okay. Finally, these questions. I don't know. I have a very interesting, fondness for these questions. So there's one possible solution to the equation above. I might even show you all both possible solutions. And assuming x is greater than 0, of course. So if you multiply this x cubed to both terms, this term and this term, well here, don't multiply the exponent, you're going to add the exponent. It's the same base, now you just add the exponent. Alright, so it's x to the power 5 minus 5x cubed equals negative 4x. Okay? And I'll just bring it to the other side. We have x to the power 5 minus 5x cubed plus 4x equals 0. Now let's factor it. Let's do this over here. What's the biggest common factor I can take out shell? X, right? What do I have now? I have x to the power of 4 minus 5x squared plus 4, right? Simply put, I'm just factoring, and there equals 0. Okay, so one easy solution is to say x equals 0. Boom, done, but obviously we can't do that because it says if x is greater than 0. Obviously, they actually want us to prove that we know our algebra in this one, which is fine. We can still do that. So we just got to factor this part out now further. There's x to the power of 4, so I'll do that part over here. So again, just don't think too hard about this one. Your C term is positive, so it's probably going to be something like x squared. Trying to think. Okay, so it's going to be x squared. What are some factors of 4 which add up to 5? They're probably thinking 1 and 4, so it's probably going to be like x squared minus 4 times x squared plus 1. Or no, never mind. It's both minus in order to get the positive 4. Yeah, there we go. So we get x squared minus 4 times x squared minus 1. So we can see that x squared equals 4. And that's a positive solution, so x equals 2. The other one is if we say x squared equals 1, the positive solution would be x equals 1. So we can say x equals 2 or x equals 1. Maybe I'll go with 2 if I like that number more. Or just whatever I solve for first. But either way, 1 or 2, those are both the solutions. So, just depends. Okay. Alright, number 17. This is also a straightforward one, and luckily the left side already has common denominator, so we don't have to change anything there. 7 minus 4, 3. We have 3 by 9x on the left side, or in other words, x by 3. On the right side, what do we have? 1 by 4 is 3 by 12, plus 5 by 12 is 8 by 12. 8 by 12. So we can say that x by 3 is 8 by 12. Cross multiply now. We say that 12x is equal to 24, so x equals 2. Okay, and there's your answer, x equals 2. You can plug it in here, you'll get what, 7. So 7 minus 4 we said is 3 by 9x times 2, you'll get that 6 by 9. Okay, and then here, well, what was it? It was 8 by 12, right? I mean, you can further simplify this, right? Divide by 3, 2 2/3, and 8 by 12 divided by 4 is also 2/3. So yes, x equals 2 is the answer for number 17. And number 18, we got an angles question. If you know all your angle rules, these should come just like that. Okay, so here we go. Two isosceles triangles are shown above. If 180 minus z is 2y and y is 75, what is the value of x? So this x is an exterior angle, right? It's going to be the sum of this angle z and this unknown angle, whatever that unknown angle is. Okay. What else do we know? We know that that these two angles are equal. Why? Because it's an isosceles triangle. This side and this side are equal, and this side corresponds to this angle, and this side corresponds to this angle. Okay, it's just the opposite. The angles and sides are opposite of each other. Those are the ones that correspond with each other. Okay. So yes, that's how you do it. Okay. And so so what are these two angles the sum of? Well, the sum of these two angles are not only the same, but they're equal to 180 minus z, right? Because it's a triangle, and a triangle angles add up to 180, and it's 2y, which means that this is equal to y, and this is also equal to y. And so that means that x is equal to z plus y. We know what y is, so we're good on that front. But what is z? Now we got to kind of solve for z, right? So if this is 75 and this is 75, then what is it? Actually, they already told you that. Well, they're giving way too much information for this problem, honestly. This problem should have been made a lot harder. Anyway, so 75 plus 75, 5 plus 5 is 10, 14, 15, that's 150, so z is 30. So it's just 75 plus 30. So 75 plus 30 is 105. That's the answer to number 18. Ooh, what a good problem. I think we're going to close off strong with these last two. Alright, at a lunch stand, each hamburger has 50 more calories than order of fries. So I'll say x is equal to, I'm going to use x in mind for this one. 50 plus y, where I guess x is the number of calories each hamburger has, and y is the number of calories each order of fry has. If two hamburgers, so 2x and 3y, this is the system equation for calories, will give us 1,700 calories. How many calories does each hamburger have? We've got to solve for x. Okay, so to solve for x, I guess the easiest thing to do would probably just, what would the easiest thing to do? I guess rewrite this equation. We can see that y is equal to x minus 50. Okay, good. So, yeah, just substitute it in there. So we have 2x plus 3 times x minus 50 equals 1700. So we're going to multiply this out. We're going to 2x plus 3x is equal to, and then I'll just say 1700 plus 150, because this is going to move to the right side and it'll become positive either way. So I'm just kind of combining those steps. So we get 5x equals 1. 7 plus 1 is 8. And then the 50, 1850. Then we got to do 1850 over 5. I'll do that over here. 1850 over 5. 5 times 3 minus 15 is 3. Right now the 5 we get 7. And then the 0 carries over. So x is the number of calories in a hamburger. We get 370. I'm not going to check my work, but that's how you solve it. It should be correct. Either way. Our last one, number 20. I think this might be like my favorite problem because of like just the way it's. We have two triangles, I believe. Triangle ABC. That's a right triangle. I'll make this over here just to give myself more room. That was horrible. I'm gonna make a better right triangle. Let's see. Straight line. Straight line. Yeah, good enough. And boom. Let's just keep this going. Okay. So A, B, C. There's your right angle. The measure of angle B is 90 degrees, BC is 16, AC is 20. Okay. And you can figure out the hypotenuse if need be, I guess. Or sorry, they're giving us the hypotenuse. We don't know what AB is. This is 20. There we go. Okay. So BC is 16, AC is 20. Triangle DEF is similar to triangle ABC. So I'll make that one right over here. And I think it's saying so vertices DEF correspond to vertices ABC respectively. And the side of triangle DEF is 1/3 length of the corresponding side of triangle ABC, which means DEF is smaller than ABC. What is the values? F. Okay. So what can we do? Sine. I feel like sine F would correspond with sine C, which should be opposite over hypotenuse, if we can find our opposite side. And I believe that this is a 3-4-5 triangle. 3-4-5, right? As you know, this 3-4-5 Pythagorean triplet. You should. And I believe, let's see, the 4 they probably multiplied by 4. Yeah, they probably multiplied everything by 4. So, yeah, let's take this, and then on the left to right, multiply by 4. So our side lengths are from smallest to largest, 12, 16, 20. So this should be 12. And then the sine should probably just be, well, let's see, opposite of hypotenuse. So 12 over 20 divided by 4 is 3, divided by 4 is 5. The answer is 3 by 5. Okay, or 0.6 if you like using decimals. And notice something, y'all. I did not use this information. I didn't even make a second triangle DEF. Because here's the thing, y'all. Let's say you were to divide by 3, I guess. You would get what? You get 20 over 3 over 12, or you get 12 over 3, which is 4 over 20 by 3. You'll still end up with the same answer while you're dividing by 3 on both sides, top and bottom. It's like times 1 by 3 times 1 by 3, something like that. So that's why there's no need of making a second triangle. That's actually going to take more time. And so that's why, because they're similar triangles, right, in vertex C, it says corresponds with vertex F, respectively, of course. So that means sine f equals sine c. So just find sine c then. Find your missing side, and then solve. Because either way, you'll need your missing side, right? So just use this triangle. You don't even need to make your second triangle and worry about 1/3 and all of that stuff. No. Just understand which angle goes with the angle you're looking for, which ones correspond, and then just find that value. For angles, it'll work. If they're asking for the side length, then yes, you have to find that side length respectively, but if they're just asking for an angle, one triangle is all you really need. I don't think I've solved the problem with this approach yet, but it works too. Of course, you could do this like this, of course. It'll be, or you can write it as 4 times 3 over 20, 12 over 20 to 6.6. Same thing. In the end, you'll get to both places in the end. But yeah, that's how you can solve the problem. Anyway, thank you guys so much for watching. I might see you guys back for the math with calculator section for practice test number 3. Thank you all for sticking around. See you next time. Keep practicing more problems. Any questions, concerns, comments, anything, let me know down below. And just thanks for watching. And this was fun, y'all. I actually enjoyed this towards the end. Very, very fun stuff. So yeah, thank you all for watching.